What is up, YouTube? Mr. Keen coming live in the studio. Here are the questions. Oh, no questions for the day. We're just going to go straight into it. By the end of this video, you should be able to connect momentum to why certain players take more damage in football collisions. Specifically, here's the EQ that you'll be answering at the end of the video. Why is it that when a 350-pound player collides with a 200-pound one, only one goes to the hospital? Why is that? Has to do with physics. Okay. So if you're watching this video, please get a pencil, a piece of paper, and I like Cornell note style. So on the left side, words, the right side, pictures that'll help you associate the words with the concept. Okay? And if it has a star, it's very important, so I want you to write it down. Okay? First thing, think about this. Which has more momentum? The rock or the person? And why? And I want to give you a hint. Assume that these two are going the same speed. Which one will have more momentum regardless? Okay? Hopefully you know momentum. You can think of it as like a oomph or a source or like a force. So momentum is mass times velocity. You need to know that. Momentum is mass times velocity. The shorthand or momentum is represented by the letter P. Why is it P? Why isn't it M, Mr. Keen, or O, or something like that? My guess is because M was already taken by mass in meters, N was taken by newtons, O was taken by ohms, so I bet they just went down the alphabet to P. Okay? But that could be good news because the P has not been taken yet. Momentum could be called something else one day. It could be even named after you or me. It could be the Connor Keen unit, or it has this many Connors as the unit. You never know. Okay. So you should know momentum is mass times velocity. So the reason why the rock has so much momentum, not only because it's fast, but because it's heavy too. Okay? Next, I want to do some review. Momentum is mass times velocity. Force is mass times acceleration. What's the difference here? What's the difference? In these pictures, we're supposed to be a hint. So pause the video now, try and answer. What's the difference between momentum and force, or velocity and acceleration? Try and remember the difference. Hopefully you remember that acceleration is when you're changing speed. So when you're putting in that NOS to make the car go fast. Whereas if a car's on cruise control, it's not going to be accelerating. So we wouldn't use force for a car that's going the same speed, but we can use momentum. Momentum can be used for constant or for changing speed. You need to know that. Whereas force was only for changes in speed. Okay? And I want you to pause this video now. If you see a semi-truck and a little smaller truck going the same speed and they have a head-on collision, which one will deal more damage? And then which vehicle has more momentum? Okay? And I have a video to help you remember. So I have a compilation of car crashes. I want you to watch which cars take more damage. This is why I shouldn't drink and drive. Ugh. Hate to see it. Hate to see it. You could see the small car took a lot more damage than the semi. Oh. So you'll see at the end, that is a truck and that semi was able to flip it. And the reason is because the things that have more momentum, objects with more momentum, give more damage and they take less damage. So that semi-truck maybe going as fast as that little car, but the semi-truck has a lot more momentum because it's a lot heavier. So the semi-truck won't get as badly hurt, and it'll make the other car hurt a lot more. That's why you saw a lot more parts falling off these cars compared to the trucks. Has to do with momentum. Okay, let's pause it now and write that down and draw a picture. Next, I have a football clip for you. Interception, here we go. Oh, skirt. But dang, he got trucked. But the big guy just totally knocked him out. Okay. So I want you to do this in your notes. Who has more momentum and how much more momentum do they have? Okay? Try and figure it out. Use the formula mass times velocity to get momentum. So the big guy is 6'11", and he's 150 kilograms, which is around 340 pounds. And he's moving at 2 meters per second, whereas the other guy is my height, 5'10", and he weighs 75 kilograms, and he's moving 3 meters per second. Who has more momentum and how much more momentum do they have? Okay, try and do in your notes. Your answer should be less than 100, but more than 0. Okay? Hopefully you noticed all you don't care about the height, just about the m and the v. So you take 150 times 2 to get 300. You take 75 times 3 to get 225. To get the difference, 300 minus 225. So this guy has 75 more kilograms per meters per second. So every second he gets hit, he's getting hit with 78 kilograms more. What is like if a body is just thrown at you every second. Okay? That's why it hurts so bad. 75 kilograms is a lot. He pretty much got hit by himself, and that's why it knocked him out. Okay? I have another story for you. There's a charity called Make-A-Wish Foundation. What Make-A-Wish Foundation does, they grant wishes to kids with cancer, usually that are terminal, which means that they have small chances of surviving. And a few years ago, one kid, huge soccer fan, he's like, I want to block one of Messi's penalty kicks. Very hard to stop. You may know Messi as the best player in the world. He used to play in FC Barcelona at the time. I want you to pause the video now. What do you think happened when Messi shot on the kid? Okay. Hopefully, he figured Messi, he's not holding back. So actually, the boy broke his arm because he did block it, but the force was so great, the momentum was so great, it flew his hand back, and he broke his arm for blocking it because the momentum was too much for him. But it wasn't all bad. Messi and the team felt so bad that they actually all signed a ball for him. So, what this story represents is momentum. So, I want you to try and calculate the momentum of the ball that Messi kicked. That's what we're going to start with. Okay, so Messi kicked the soccer ball that weighed 0.5 kilograms and it moved 50 meters per second, very fast. If the boy's arm weighs 5 kilograms, we're going to try and figure out how far back that arm flew. But first, we have to figure out what's the momentum of the ball. Okay, once you got that, remember it's m times v. So you take the mass of the ball times the velocity. So momentum of the ball is 25. But now this is the harder part. How much did his arm fly back when it got hit by the ball? Okay, so we know momentum is conserved. We learned that yesterday. So if momentum is conserved, that means the momentum of the ball should have gone into the boy's arm. So the momentum of the ball before should equal the momentum of the boy's arm after it got hit. Okay? You can use this formula to help. M1 and V1 represents the ball, M2 and V2 represents the boy's arm. Okay? You have all the information you need. Pause the video now and try and solve the question for the boy's arm's velocity. Okay? Hint, since momentum is conserved, you should set the boy's velocity and mass equal to 25. So you have the momentum of the ball is equal to the momentum of the boy's arm. So 25 is equal to the mass of the arm, 5, times the velocity. And use algebra to solve for the velocity of his arm. So you take 25 divided by 5 to get 5 meters per second, or negative 5 meters per second if you want to represent that the arm is flying backwards. And that's why I broke it, because the arm flew back so fast. Okay? So last thing to put in your notes before we go, please write momentum is conserved, which means like the momentum from the ball that Messi shot went into the arm. So momentum is conserved. All the momentum from the ball went to the boy. It's not like the momentum came out of nowhere, and it's not like it just disappeared. All the momentum from the ball went to the boy. So that's all I want you to remember, is that the momentum before should equal the momentum after. All the momentum should be accounted for. Okay? And that's the formula you use if I have a question like that again when you're trying to find the mass and volume of an object. Okay? So last thing, please write a summary in your notes to explain what is momentum to a friend and answer why only the small player was hurt in this collision. Okay? Thank you so much, everyone, for staying with me. Have a great Wednesday.